And for this last example in this section of notes, I'm pretty sure you should have seen this example before now. And that is when I'm rolling 2 dice, it's easiest to show the outcomes as opposed to a tree diagram to just in table format. So I'm going to enter the possible outcomes for die 1, and then the possible outcomes for die 2. And we could construct this problem in several ways. We could look at the difference between them, we could look at the product, but most typically you're looking at the sum. So then I would just list what the sums are. So adding the 2 dice together. Oops, what the heck is that? That's better. I struggle with talking and writing at the same time. So now, if I want to look at some of the probability questions, I have to keep in mind what it's asking and how this table will be useful to answer that question. So if I look at probability of doubles, it's not in fact talking about the sum. It is in fact talking about the face on the die. And so where do I have, a 1 and a 1? Where did I get a 2 and a 2? Where did I get a 3 and a 3? And of course that happens along this diagonal. So that is 6 out of, in case you haven't counted yet, there are 36 outcomes. Versus the second one, I'm looking at a sum greater than or equal to 8. So greater than or equal to 8, I would be looking at all of these sums, which is 5, 9, 10, 11, 12, 13, 14, 15 out of the 36. And of course, several of these can be reduced, so I would expect you to do that. If I look at the sum less than 3, well, I only have one sum that's less than 3. That's the sum of 2. So 1 out of 36. Notice it doesn't contain an equal to sign, so I can't count the 3's. A sum of 9, that would be those 4. I roll a 5. So now it's not talking about a sum of 5, it's talking about the face. So if I look at where did I roll 5's, a face of 5's, well, all of these had a 5, and all of these had a 5. And just remember, so that's 1, 2, 3, 4, 5, 6 in the row and 6 in the column. But be careful, don't count this one twice. So really 6 in the column, and then 1, 2, 3, 4, 5 additional. So that's 11 out of 36. And then the last one, notice it's a 3 given a 5. So now I have to be, well, actually, before I look at the table, I could do this using my formula, right? That would mean a 3 and a 5 out of probability that I rolled a 5. So now, I already know the probability that I rolled a 5. It's 11 out of 36. And where did I roll a 3 and a 5? Well, I rolled a 3 and a 5 right here. And I rolled a 3 and a 5 right here. So that was 2 out of 36. And then with some math magic, I'll end up with 2 out of 11. Now, if I'd said probability that I roll a 3 given a 5 and I just use the table, well, I would still need to be in the 5 column or 5 row. And we just finished saying that that was 11 outcomes, so I know 11 has to go on the bottom. And then once I'm in either the 5 column or the 5 row, I needed to see how many of those entries were a result of me also rolling a 3. And of course, these 2 entries are the only place in the 5 column and the 5 row where I also rolled a 3. So I get the same answer. All right, we will stop there. We will talk about Venn diagrams and the remaining problems tomorrow.